This is from chapter 4, overusing the Colorado. It's going to be on groundwater, and it's going to be on a little bit on fracking, bottled water, and water pollution. So we're starting to look at some of the challenges, some of the issues to sustainably managing our water supply. There we go. Okay, Colorado issues. So the Colorado River and its basin, which starts all the way up in the Colorado Rockies, supplies the water for, what is it, 5 or 6 states. So it's absolutely vital to 5 or 6 states in the west of the United States, right? And each state has a budgeted amount that they can take. And that's what they're talking about, is the Colorado water budget. So I think it's California. I think we're at 5.4 million acre feet. It's a lot of water, but we've been designated that. And we'll get to that in a moment. We were going over that. So each state has to take their designated amount, and then in the end of the day, there needs to be enough water left over to go across the border into Mexico, right? Because there's a whole bunch of people living across the border in Mexico, below Blythe there, that need the water. We also have a major environmental treasure there, which is the Sea of Cortez, right? Down there into Baja, okay? So, and the Mexican government has a treaty with the United States to make sure they get a certain amount of water. And that just got ratified, or if that's the right word, or re-upped recently to where now they've been guaranteed that they'll get a certain amount of water, okay? So the issue, though, is even though we've budgeted all this, they're seeing that there's declining runoff, declining water supply going into the Colorado in the first place, right? Global warming, and then that's being reflected in the storage in Lake Mead and Lake Powell. So they're seeing that Lake Mead and Lake Powell, I got to visit this several times in the last few years, they were just way down, okay? And there's a 50% chance that the functional storage, in other words, enough, what they're talking about here is if there's enough water to get us through the years, will start to be impaired by 2021. So that's not very far away, right? Other side effects, if the Colorado starts to fail as a major water supply for all these states, is hydroelectric. We talked about that the other day, right? We depend, like we said, amazingly enough, most people don't realize, in this area we depend a lot on hydroelectric, right? I think it's about 20% of California's water electric supplies from hydroelectric. So, and it's mostly coming from these big dams on the Colorado. All right. So the Colorado River System Conservation Program, created in 2014, will pay farmers and urban users to conserve water across the watershed. Okay. Do you happen to notice the date? 2014. So we're things are already quite bad, and we're now only really starting to get serious about it. A shortage will be declared if Lake Mead, so this is what this plan is. So we'll go into kind of an emergency situation if Lake Mead drops below 1,075 feet, okay? That's above sea level, right? So in 2015, if you look at that, Lake Mead was at 1,089. So it's barely less than 20 feet. That's 14 feet above the minimum. So we're already at this emergency situation. And as we all know, other than last year, which was decent in the Colorado Rockies, we're still in a perpetual state of drought right now. This year, I'm not sure what their situation is up here, but this year we're way below normal in this area for water, for rain. Transferring water rights from the Imperial Irrigation Districts to San Diego County was finalized in 2003. So another big pressure on this is the shift that's starting to happen of taking agricultural water for agriculture, and moving it towards urban. And so San Diego County has been out there for years aggressively trying to buy water from the ag producers in the Imperial Valley. And so again, that's going to shift this whole balance of how we use Colorado water, right? Because the big aqueducts, if you remember, there's two systems. There's two of them. The Colorado River Aqueduct comes in right at Palm Springs, basically, and then the American Aqueduct, which is further south of that, okay? And California was restricted to 5 million acre feet. This is about 3 years ago. Beginning of the year, they said, you guys cannot use more than that. And we were using quite a bit more than that. We were actually over pumping. We were going over our allocation. The Minister of Interior said, if you go over in the future, you'll be fined. So we had to cut back. Okay? Salton Sea, real quick. So the agreement, a couple of different points there, but around the early 2000s, when they first started pumping water to San Diego County, instead of using it for ag water, well, the big problem is that there's 38,000 miles of subsurface drainage pipes. So they irrigate, whether it's drip irrigation, flood irrigation, pivot system irrigation, water goes in the ground, and then they drain that water away like a reverse sewerage pipe. They drain that water away, and ultimately these drainage pipes go into the Salton Sea, okay? Which gives the Salton Sea relatively fresh water, right? It's not salty water, because we'll find out in a moment that the Salton Sea is already hypersaline, right? And so these drainage pipes are what allow them to balance the Salton Sea, right? Because the biggest issue in the Salton Sea is it's getting too salty, hypersaline. Okay, but now all of a sudden we're shipping that water out before it even goes to ag. So guess what? We're getting less water back into the Salton Sea. Okay, so even that drainage though, how did it happen that it got so hypersaline? First of all, it's a blind lake. It ultimately was a dry lake that over time historically has got filled with flood events. The last time it actually got filled, they were actually building the Colorado River Aqueduct. And this is years ago, I think in the 30s. And they were building Colorado Aqueduct, and they got a big storm event, and it broke its banks, the aqueduct did. And it filled the Salton Sea, right? So you guys probably know, just real quick geography, Salton Sea is below Palm Springs, right? And so, but over time, this ag runoff has been very high in dissolved salts, and it's getting fertilizer, right? So we're talking about this nutrient loading that's going on. We're putting extra nutrients and extra salts back in the Salton Sea. Of course, it's sitting out in the desert. It's blind ending. It's got no outlet, no rivers actually running into it of any significance. So it's also evaporating and leaving all that saltiness behind as well, right? So it's got lots of salt load coming in, and it's also evaporating, leaving us a lot of salt behind. So ended up to where it's 25% saltier than ocean. Was one of the most productive fisheries in the USA. I don't know if you've known some keen fishermen, but the place to go fishing used to be the Salton Sea. But over time, they've had all these fish die-offs to where I don't know that it's much of a fishing destination now. Okay. The other thing the Salton Sea does environmentally, it's critical to migrating birds. Okay, we have this thing called the Pacific Flyway, where birds are migrating, obviously south in the winter from up north, and it's either a final stopping spot for certain species like the snow geese, or it's just a stop-off spot for them on their way further south, migrating. Okay. And several endangered species, right? I've spent some time there. It's one of my favorite places to go. Geese, there's an extra E there. But these snow geese literally will cover the horizon. It's the most unbelievable thing. I estimate a couple 100,000 of them at one time. And it's really cool. It's a spectacle to see. And they're these beautiful white birds anyway. So very cool. So the food chain begins with, for the birds and everything else, begins with algae. And so if the lake's healthy, that's great. But if we get too much nutrients from ag runoff, we get algal blooms, right? And they could be of those blue-green type of algal blooms that actually will have human health effects. We looked at that in one of Matt's lectures the other day. But they will at least deplete oxygen and result in die-off. They use up all oxygen. The fish don't have enough oxygen dissolved oxygen, and the birds die. The fish eat what's left. Some of the birds eat what's left over, and there's bird impacts as well. So that whole ecosystem goes into a tailspin. Okay. All right. Salton Sea. People, depends how you look at it. Some people look at it, oh, well, you know, man made mistake. Just let it go. It's not a problem. Well, yeah, but the environmental issues are important. The human issues are just as important. So they've done some studies recently that particulate matter, PM10. PM10 is a kind of air pollution that's basically dust and particles. PM10s are the particles, 10 microns or less, that get into your lungs and your lungs can't get rid of. So cause COPD, emphysema, all that stuff. Really serious issue. And not only that, there's lots of toxic salts in that dry lake. So if we let that lake just dry out, like some people would say we should do, don't worry about it, just let it dry out. Those winds blow directly towards Riverside and the whole of the LA basin, and they predict one of the most catastrophic health issues with people living in the LA basin. I mean, I don't know about you guys, but I grew up in a time when I didn't know anybody that had allergies and emphysema and all that, but now everybody has them. And I believe it's already related to this. Our lungs just can't deal with all the stuff that we're being thrown at us, right? But it could be huge. So we've got to manage this. One of the ideas is to put up a big berm, a big wall of dirt right down the middle, and they would let the southern part of it just dry up, and bad luck. The part above that, they would try to balance it. One of the ways they would try to balance it is they would try to get the alfalfa farmers to allow 25% of their land not to be used, to go fallow, okay? And then they could take that water, and instead of shipping it to San Diego this time, it could go into what we would term environmental use, right? Remember our 39%? And then that could balance the salinity and keep the ecological balance in the Salton Sea, okay? So really cool project if somebody wants to do a report on this one. Really, really interesting. I'd encourage you to go visit this place. When you get there, you're like, oh, just a kind of a stinky body of water, but it's fascinating, especially this time of year when the birds are still there. Okay, so groundwater policy, okay? Talked a little bit about this, but this is all in the context. We just talked about the context for the Colorado is we get so much of our water from the Colorado. Well, for most parts in California, especially in the south of California, it's all about groundwater, right? Everybody in the class now knows that here locally, all our water comes from underground, right? We get some drainage in it, but it always ultimately goes in the ground, then we pump it out, right? Only one exception. There's only one place up here, one business really, you'd call it, that industry that gets its water straight from the aqueduct. Do you guys know which one that is? The only one is the High Desert Power Plant. They made a special deal. They get their water straight from the aqueduct. Everyone else gets it out of the ground. So really important we understand. And then we've also started to realize enough that policy, the laws, the regulations really are the driver. That's what kind of tells us what we can and can't do, right? And so these groundwater policy is really important, okay? And the biggest thing is we need to know that traditionally water rights followed land ownership, right? So if I'm over the piece of, if I've got 5 acres like where I am, then traditionally in the way that water rights work, I own the water underneath me, okay? And that was cool, except that people for 150 years just totally abused that. They just kind of assumed that the water underneath us was unlimited. And we now know that it absolutely isn't, right? So after this chaotic and environmentally destructive use, in 2015, most people would say the most important piece of legislation in California was passed out of anything. And that's the Sustainable Groundwater Management Act. It's also called SGMA. And that just says each groundwater basin, and we're the Mojave groundwater basin, we have to manage our water sustainably. And if we don't manage our water sustainably, those groups and people will not only be forced to cut back on their use, but they'll also be faced with huge fines. Okay? Now it's law. You can't just mess around with it. And that was in response to huge amounts of groundwater overdraft, right? Just think of your bank account. This is our water bank account. We're overdrafting, okay? Especially in the Tulare Lake and San Joaquin basins, okay? So Tulare Lake is just north of Bakersfield. San Joaquin is north of that. This is the San Joaquin Valley, the breadbasket of the world, the richest agricultural region in the world, right? 400 different crops, big crops, important crops. So when this has happened for 150 years, but it was continuing, especially in drought years. And basically, it's a really simple thing. When the farmers, when the city, let's say the city of Fresno, our local cities, when they couldn't get water from let's stay in the Central Valley, from the Central Valley Project, when that got cut back. Do you guys remember, I think you made it to that part of the field trip. We were standing on the edge of the river there, and we started talking about the allocation that we get from the State Water Project. And we were told that 2 years ago it was cut to 5%. We only got 5% of the water that's allocated. Well, then what used to happen, up until now, still happens, because this only comes into play officially by 2020. It has to be in play. I think it is. But then all they used to do is just turn on the groundwater. They all had wells, and they just turn on their pumps. So the farm can still keep irrigating, the city can still keep, you guys can still keep taking your long showers, all of that stuff, because we just turn on the pumps. Well, that's going to stop. That has to stop under this. Okay? We are fortunate, and we've talked about this several times, we're going to go over it again, that we already were doing this because people sued each other. City of Barstow, years ago, in the early 1990s, before the 1990s, sued us up here to say, hey, you guys, you're taking away our water before it can seep through the sediments and get to us, right? And we did an adjudicated basin, a judge's order on how we're going to manage the water, right? And so that's called the Mojave River adjudication. It's a big deal. Luis will say that when in his work, this comes up, 10 times a day?
All the time.
All the time, because it's the bottom line, right? So basically what happened here is we locally were pumping over 200,000 acre-feet. And this is back in the 1990s. And our natural supply, and we've talked about this in the Mojave Water Story 1 and 2 online, those lectures, and Matt went over this. We get some water coming towards us. It comes down, flow through Deep Creek, comes down through the sediments. It's about 50,000 acre-feet. We were using 200,000. And therefore, we were, for many years, overdrafting our water basin, right? So then what they did is said, okay, judge got involved, there was a lawsuit involved, and they asked the big water suppliers to stipulate. That's a legal term saying, basically, we release our rights. Because the city of Hesperia could have said, as did Jess Ranch. Jess Ranch said, no, the water under us belongs to us, and we don't care about your adjudication. We're not going to stipulate. We're going to stay outside of it. Okay? And it was highly controversial, and obviously people were really angry. Responsible people, in my opinion, stipulated. They said, okay, I release my rights. I'm going to work as a group here. And what they did is they established water rights based on 2 years of pumping. So back, I think it was 89, 90, or 88, 89, somewhere in there, they measured how much water you pumped for 2 years. And it wasn't just little private people. This was the big water companies, ag producers. And they said, okay, based on that, you use 100 acre-feet of water a year. That's your water right. And that's where they started. Then based on Mojave Water Agency, and we're going to see how they do this when we go to their science and technology workshop that we're going to go to, they measure the overdraft. They've got a one of the most sophisticated scientific research engines, facilities, groups in the state. They measure what's going on with the water supply, right? They've got, what did he say the other day? 6,000 wells that they measure, wasn't it? 6,000? Yeah. 6,000 wells, and it's on GIS, and they can work. And then every year they have to go back to the judge. And every year the judge looks at it in each region. We have 5 regions here. We're in the Alto region. They looks at us and says, okay, you're overdrafting or you're not. Therefore, I'm going to cut your water rights by 2%, 5%. Up here, because we're fortunate and we're near the source of the water, I think we're only ramped down. That's called ramping down. We cut your water rights. So I think we're only ramped down, correct me if I'm wrong, Louis, I think we ramped down about 20%. So if you had 100 water rights, you now have 80. And that's all you can pump, right? I'm going to come back to that. But down in Newberry Springs, they're down to less than 50%. Okay? They ramped down last year, I think, 2.5%, because they're still in an overdraft situation. And it's very, very hard for them because they're like, hey, this isn't our fault, guys. We're just not getting enough water. So the problem is continued. So the adjudication does a great job of balancing things, but it's far from perfect. So let's see, what else I was going to say? Ramp down. If you go over your water rights that you own or lease, then you have to go buy water from the other part of Mojave Water Agency called their water master, and you have to pay the current rate, about $7,000, $8,000 an acre foot right now. And so you have to pay extra to get your water rights. Okay, so you can pump more, you got to pay for it, and then what they do is they take that money and they buy water from the state water project to recharge, right? So that's how they make up that difference. Okay, all right. So groundwater overdraft, it caused subsidence, damage to roads, buildings, canals, and low coastal areas, right? Up in San Jose area, they had problems with this. They also causes a little bit of compaction. So normally it's just like a sponge. You overdraft it, and if you've got water in a good year or you buy it, you can recharge it. But it does compact, especially the silty clay sediments compact. So by overdrafting does have a bit of a negative effect in the storage capacity of the groundwater basin in the long region. Saltwater intrusion, if I pull out water here, fresh water, and there's salt water in the ocean out there, it's just going to come in. And that's a big issue in places like the Salinas Valley and Orange County, right? So that's another side issue. Obviously, that's not one we have here. But those are 2 problems with groundwater overdraft. Okay? Groundwater pollution. Polluted groundwater is one of California's biggest challenge, and is aggravated by old thinking that basically says if we put it in the ground will clean it, right? That's what most people think about septic tanks. As long as it goes in a septic tank, it'll clean it. Well, it will clean the bacteria and the microbes in the soil will clean a lot of things. We'll see in a moment, it doesn't clean all the hormones and all the pharmaceuticals and all of that. There's no effect on that at all. That stuff goes straight through it, okay? And then the book goes into several different kinds of contaminants. Mercury and sulfuric acid was used in gold mining to pull the gold out of rock for years. The Mountain View mine out beyond Baker had a big problem with this not even 20 years ago, and so they've got a huge mitigation project going on out there right now to get that mercury and sulfuric acid out of the system out there. Arsenic and chromium-6, They both come from naturally leach from rock deep down, so they're there anyway. But then we'll find out chromium-6 at Hinckley. They used it to clean their pumps for the gas, the pressure pumps, and they contaminated a whole plume. Plume is an area of contamination. Then we've got radioactive minerals that were mined in places like Colorado River Basin around Moab. They've got huge mitigation projects there. I've seen some of those to take that. They actually are taking the overburden from those mines. They're putting them in big metal containers, and they're actually shipping them somewhere else in Utah, and they're burying them. So they're literally taking big piles of dirt that are high in uranium. They're putting them in these, and then they're taking them and they're burying them somewhere in Utah to get rid of that extra uranium. Because in the old days, they took the uranium they wanted, and then used for atomic bombs or for nuclear energy, and then they left a whole bunch of it still in the rock that they'd mined. Perchlorate, rocket fuel, we had a problem with this not too long ago in Barstow. PG chromium-6. MTBE is a gasoline additive. That's why you'll see a lot of gasoline stations have to remove their tanks and replace them with new ones that aren't leaking. I don't think MTBE is used anymore. And then two-stroke motors, outboard motors, just pollute directly into the ocean, into the lakes anyway, right? If you've ever had a two-stroke motor, you go along behind it and you see that little film lying on top of the water. They're just dirty. So, all right, fracking, okay, resulted in a boom in oil and natural gas. And what they do is they drill down the very deep wells, and then they go sideways. Okay, got this new technology can go sideways, and then into those areas they put in solvents, stuff that can take oil that you normally wouldn't have got. It's very thick, viscous, low quality. It's actually, some of it's just like a gunk, and they basically dissolve it, right? And the stuff that they're pumping in there is hydrofluoric and other acids and a bunch of solvents that to this day they're not actually forced to tell us what they are. There's a law that says that they don't even have to tell the local people what's in that stuff. And so their contention is it's going so deep down, it stays down there, it can't contaminate groundwater, it can't come up. The only time it can contaminate above ground is when they're recycling it or putting it in ponds. But you know, you've all seen, I'm sure you've all seen the videos of a guy turning on his tap water in his house and then lighting a match, and it basically catches on fire. You guys seen that? Look that up. Look for fracking and water on fire or something. It's pretty incredible. So there's a lot of controversy because a lot of people believe that this process has got a lot of long-term effects, okay? It can contaminate drinking water aquifers is the biggest one, okay? Used for years, or what really surprises people is in the most stringent environmental laws in the world, California, it's used right off our coast here, right off Santa Barbara. If you go along Santa Barbara, look out, you'll see those oil derricks. Those guys have been using fracking for years, okay? And they pump that oil back onto the coast. If you get up just above Santa Barbara, you'll see their big storage containers. And as you probably all know, they had a big break in that probably, 3 years ago? One of those lines broke and they polluted a bunch of the ocean. And if you've ever been around crude oil, don't even think about it as being the oil that you put in your car. That stuff's like kind of nice. This stuff is sticky. It sticks to things. You can't literally even use soap to get it off your skin. It's really, really polluting and nasty. Okay. So voters measured in 2013 better regulation and including notification. See, California at least now. I'll correct myself. The rest of the country, you don't have to tell them what chemicals they're using, but California you do. Okay? Drinking water management. policies established originally under the Clean Water Act in 1972. And the main thing we need to know is each contaminant, each thing that we're concerned about in our water has a minimum contamination level, MCL. So like chromium-6 has an MCL. When we go out to, now it's getting really hot in here, huh? Let's see what we got here. Let's turn that off. By the way, you guys can go if you like. This will be, the video will be up, but make sure it's still recording. Yeah. These MCLs are what kind of govern what agencies and people have to keep the contamination level too. So for example, arsenic. Arsenic, they had a certain contaminant level. I think it was 50 parts per billion, or parts per million, not even sure on that. And then a few years ago, they lowered it down to 10. So for example, that became a big management issue for folks out in Baldy Mesa. All of a sudden, the water, arsenic was naturally occurring in the ground from the rocks, right? All of a sudden, they were over their minimum level, minimum contamination level. So they had to start mixing water, okay? So in certain drinking water management, this is a great career, by the way. There's a distribution license you can get and a treatment license you can get. And these folks make a lot of money. And there can be up to 6 steps that they clean water and disinfect. Here in the desert, most of the time our water is actually right out of the wells is great quality. And often they don't have to treat it at all. Okay? So one of the things they might have to do though is if there's contamination from septic systems, they might have coliforms, bacteria in it, and they can use chlorine to do that, to kill it. But chlorine you have to be careful with because chlorine also can cause trimethylamines. That's the one I'm looking for. Chloramines. So if you get chlorine into the supply itself, then you can have problems too. Okay. You can also use ozonation, where you hit it with ozone, or ultraviolet radiation. When we go to BVWR, we will see they use ultraviolet radiation because it's a little safer and cleaner than chlorine. Did you have a question?
No.
All right. All right. Drinking water, another one you'll find if you like to go camping or maybe go to places that aren't able to keep their water as clean as Giardia. It's a little bug, a little microbe, and it causes very severe diarrhea. So when you go up into the mountains hiking, that's why you filter your water. Okay. Mass medication. Almost at the end here. Thanks for staying a little bit longer, Matt. Fluoridation for our teeth, for cavities. So California actually requires populations of more than 10,000 people to do that. And the controversy extends around whether we should be putting something like fluoride back into the water. And then there also are some environmental effects of that, like delayed salmon migration and deformed embryos. So what's the balance between human health and, again, the environment? Okay, so as always, there's a balance, lots of research going on in these areas. Drinking water management, folks often think that their tap water is contaminated and bad, which in the United States, in most places, especially California, we know that tap water is more highly regulated than bottled water. Okay? Tap water costs 240 to 10,000 times more per gallon. I think we've already seen this figure. And there's deceptive advertising of whether it's spring water or not, right? We talked about Arrowhead water being an example of that, right? And then, of course, the plastics. We've got to use, plastics come from fossil fuels, come from oil, and then they're very polluting themselves. So we're using more fossil fuels to make the plastic, very polluting. Some people also are concerned about contaminants from the plastic actually getting into the water. And that's it. Thank you, guys.